Alright, we'll be doing a very short problem this time, and that is calculating effective capacitance across A and B. Well, let's zoom in over here and let's see what's going on. We need to calculate what's the total capacitance between these 2 points. At first you might say, well, that's 4 microfarad. That's because 4 microfarad is just connected across it. Well, no, it need not be 4 microfarad because there are other capacitors connected, and if I were to connect these 2 terminals to a cell, if I were to connect these 2 terminals to a battery, then there's a very good chance that the battery is going to see more than just 4 microfarad capacitor, because the battery might be able to transfer even more charges, and so the total capacitance might even increase or may decrease. I think it's going to increase anyways. So let's calculate what the effective capacitance is going to be and try to find out. So let's do this. So the first question is again the same. Can we find any 2 capacitors in series and parallel? And I think we can find one, and that one is over here. This guy over here is in series. These 2 capacitors are in parallel with each other. I hope you can see that. So let's quickly take a copy of this. So let's make a copy of here. Alright, so these 2 capacitors are in parallel with each other, and the 2 capacitors in parallel are going to give me, so we just have to do 4 parallel 4, and that's going to be 4 plus 4, 8 microfarad. So that's nice. So what I'm going to do now is I'm going to delete these 2 capacitors. Who needs these 2 capacitors? I'm just going to replace them with one single capacitor. And the question now is again, where should I replace them? Well, I can replace them here, or I can replace them over there, wherever I want, because they are the same points. Well, what I'll do is I'll rub this whole thing. I don't need that. I'll rub this whole thing over here. I'm going to put one single capacitor at that point, and that single capacitor is going to be 8 microfarad. Alright, so the next step would be to copy this whole thing. We're going to go from here to here. Let's zoom in, and let's see whether we can find any 2 capacitors in series or parallel now. What do you see? Are these 2 guys in series with each other? These 2 capacitors? Well, the answer is no, because you can do a test now. And what you can do is the same test what we do. We'll send a charge Q, and we'll move it from here to here, and notice, they're going to transfer from here and here. So they're not in series. What about these 2 capacitors? Well, they're not in series either, because you transfer a charge from here to here. Notice some of them is going to split up. So these are not in series as well. The 3 capacitors are not in series with each other. But what about parallel? Are they connected in parallel? Well, they don't look like so. They don't look like they're connected in parallel. But if we analyze this carefully, let's put some dots, let's put some points. We know this is point A. So this over here must be point A. Ooh, this tells us that this capacitor is also connected across AB, just like these 2. These 2 guys are in parallel with each other. What about this capacitor? Well, let's see. This plate is connected across point A, and this plate is connected across this point is B. Oh, notice something very interesting. This is a very classic case of the 3 capacitors in parallel. They are disguised, but they are just 3 in parallel with each other, and therefore we now know what the net capacitance is going to be. We're just going to add them up. So the total capacitance, the effective capacitance between A and B, is just going to be equal to 4 parallel 8. Well, that's going to be 12 plus 4. This is just 16 microfarad. And ta-da, there is our answer. That's it. 16 microfarad is the answer. Just 16 microfarad. So I hope I was able to give you some sort of an intuition behind how to solve, so again, seemingly puzzling problems like this with a lot of connections and short circuits like this. All the time, the secret is to carefully analyze them, put dots, use the charge, throwing the charge from one plate to another, test to see whether the 2 capacitors are in series or not, and that's going to help us a lot. Alright, so see you next time.